I don't know why I stopped recording. Okay, so we're going to take that domain and we're going to say the whole denominator, x plus 3, has to be, which rule is this? What does it have to be? Go back to your little hints.
Greater than equal to?
Good. Our whole denominator has to be not greater than, oh yes, greater than, but not equal to, yeah, not equal to. Because if it were, the denominator were equal to 0, wouldn't that be undefined?
Oh, the x.
Oh, okay. And then we solve. We solve just like we're doing an equation. We're subtracting that 3 on both sides. So x is greater than -3. Oh, wait, guys, this is wrong. Sorry, it doesn't have to be greater than. Nico, you throw me off.
Sorry.
The denominator can be negative, right? Is it okay to have, like, y equals 3 over -2? Is that okay to have a negative in the denominator? Absolutely. The whole denominator just can't equal 0. It just can't equal 0. So x plus 3 cannot equal 0. Well, in what scenario will x plus 3 equal 0? When x is equal to -3. So our rule is not x equals -3. Our rule is x can not equal -3. All right, our two notations here. So for so for set notation, we have x such that x cannot equal -3. That's it. That's our set notation. The interval notation's a little bit more complicated. So for interval notation, we know we just can't equal 3. Can it equal every other number except for 3? Yeah, the only number it can't equal is 3. So the furthest left is -infinity. And then we're going to go from -infinity all the way to what number? But it can still be like -3.5, right? It just can't equal -3. So we're going to go from -infinity all the way to -3. But is -3 going to be in our answer or not in our answer? Not in our answer. So that's why we do a round parenthesis. But then we're not just stopping there, right? Because that means it's stopping at -3. What about all the numbers that are bigger than -3? Are those still okay? Yeah. So what you do now is this little U shape. It means or. This little U shape is a union. It means or. So we could have every number from -infinity to -3. Or we can also use every number from -3 to +infinity. And notice, again, I used a round bracket, so -3 is not in that answer. So this is the interval notation. All right, are we ready to step this up? You ready? Make it a little harder? Let's do it. All right, step it up. Means we're making it harder. So now I'm going to have 3 over x squared minus x minus 6. Oh, sorry. F of x equals this. F of x equals 3 over x squared minus x minus 6. And my directions are to find the domain. Hi. So we've tried to record this lesson. We've had some little bumps in the road, so let's see how it comes out for you. Okay. I want to pick your brains. Even if you don't know how to do this, you tell me what is sort of flagging you down right now. Like, what's the red flag in this problem? Even if you don't know what to do with it, what should be like, okay, this is going to be a little bit more difficult, or I'm going to have to do a little bit more work here. Nico. Good. Your main red flag here is that we have x's in the denominator. Are we allowed to have x's in the denominator without a restriction? No. So now we know the whole denominator cannot equal what number? Whole denominator is not allowed to equal 0. Perfect. Whole denominator is not allowed to equal 0. So what are we going to do? We're going to find out what would make that denominator 0. So we're going to say x squared minus x minus 6. We know that cannot equal 0. Well, how am I going to figure out what makes this equal to 0? We're going to have to, it's x squared minus x minus 6. Anybody know what's that word? Starts with an F? Factor. We're going to have to factor to figure out what makes it equal 0. So we're going to say now remember, when you're factoring, you have your x and your x. You want to find two things that multiply to the last number, including the sign, and add to the middle number, including the sign. So in your head, you're trying to think right now, what two numbers multiply to a negative 6 but add to a negative 1? Any guesses for me? Yeah.
Minus 3 plus 2.
You got it. And negative 3 times a positive 2. We're checking this out right now. Negative 3 times a positive 2, isn't that a negative 6? And then we're going to have negative 3 plus a positive 2, which is negative 1. 3 and a negative 3 and 2 are our winners. That's what we're writing inside the parentheses. So x minus 3, x plus 2. What do I do now? What do I do now?
Set them each to 0.
Good. We're setting them each equal to 0. So we have x minus 3 equals 0, x plus 2 equals 0. So x cannot equal positive 3, and x cannot equal negative 2. Those are our restrictions. Those are the restrictions on the domain. So I'm going to write this in interval notation. Set notation. So in set notation, we do our squiggly brackets, x such that, and then we write x cannot equal 3 and x cannot equal negative 2. Close our set notation. Okay, let's go on to a next one. Put a monster star on this one because this is super complicated. There's a lot going on here. So let yourself know it's important. So here we have y is equal to the square root of x squared minus 4. You're going to have to remember an algebra 2 process, but it's an algebra 2 process that everybody forgets about. So it's not like a short process. It's somewhat of a brutal process. So let's go through it and see what we have to do here. So here we have y equals the root of x squared minus 4. Step 1, what your thought process here. You're thinking, okay, I'm finding the domain. Find the domain. So because we're finding the domain, we're trying to consider the red flags. Right? It's always all real numbers except if there's 3 scenarios. Right? And remember, our 3 scenarios was 1 over x, the square root of x, or 1 over the root of x. Weren't those 3 the red flags? All right, which one does this fall under? 1, 2, or 3? 2. It falls under 2. So remember, when we have a radical, we need what's underneath the radical to be not what, or to be greater than what number? Greater than or equal to what number? 0. It just can't be negative. If it's negative, then it's imaginary, and we can't have that. So we want to take what's underneath the radical, x squared minus 4. It has to be greater than or equal to 0. It is okay to be equal to 0 because the square root of 0 is 0. That's fine. 0 is a number. It's fine. This is the part everybody forgets. So I'm going to sort of write a little note for us because this is what we all forget. Anytime you have a quadratic inequality, you must test the regions. And I'm going to explain to you what that means. Anytime you have a quadratic inequality, you must test the regions. Okay, just to break down what this means. A quadratic means x squared, right? Quadratic, anytime you call something a quadratic, it means there's an x squared, right? Inequality means the crocodile mouth. So they're saying anytime you have an x squared and the crocodile mouth, there's a certain process we need to follow, and ultimately we're going to have to test certain regions. Your first step in this, step 1, factor the quadratic. So let's write this over to the side. Steps. Factor quadratic. All right, x squared minus 4, that's a dot. Who remembers how to factor this? What does it become? Only Nico. Nico's holding up the class. Come on, guys. In the back, what's your name? Luke? Okay, Luke.
It's x minus 2, x plus 2.
You got it. It's an x minus 2 and an x plus 2. That has to be greater than or equal to 0. So step 1, we factored the quadratic. We're good. Step number 2. Find reference numbers. By setting parentheses equal to 0. Okay, what do I mean by that? Find reference numbers by setting the parentheses equal to 0. So basically, if I were to take x minus 2 and set it equal to 0, what does that mean? X is equal to positive 2, right? If I take x plus 2, set it equal to 0, x is equal to negative 2. So what are my reference numbers? 2 and negative 2. Those are my reference numbers. All right, so step number 3 now. Test regions based on reference numbers. All right, are we ready to see what this looks like? All right, so I'm sort of making a line here. And I want to know what's my smallest reference number. 2 or -2? Which one's smaller? -2. So what you're going to do is you're going to test x is less than or equal to -2. And you decide if it's if you put the equal to sign based on what's in the initial part of this. So if this were just x minus 2, x plus 2 is greater than 0, then we would just do x is less than -2. So whether you put that line underneath all depends on the original problem. If it has the line, then you keep the line. All right, so that's our first region that we test. The second region that we're going to test is between the two reference numbers. So I'm going to test numbers between -2 and 2. So we're going to say -2 is less than or equal to x, which is less than or equal to +2. And the very last region we test is bigger than our biggest number. So we're going to test x is greater than or equal to 2. And I'll show you how this works. Now, do you see in our original problem how they want our quadratic, we want the quadratic to be greater than or equal to 0? So what that means, because it's greater than or equal to 0, we want the product to be positive. We want the product to be positive. If it were less than or equal to, you'd want the product to be negative. So if it's greater than 0, you want the product to be positive. If it's less than 0, you want the product to be negative. All right, now let's do the testing. All right, so the first part tells us to test a number that's less than -2. Give me a number that's smaller than -2. -1's bigger than -2. -3, perfect. So now what we're going to do is we're going to test -3. So the way I test -3 is I plug into my parenthesis, -3 minus 2. What's -3 minus 2? Is it positive or negative? -3 minus 2, isn't that a -5? So it's negative. All I care about is positive or negative. Then I'm going to put -3 in this next one. -3 plus 2. What's -3 plus 2? Positive or negative? Negative. So I'm looking here. What's a negative times a negative? Positive. Did we want the product to be positive or did we want the product to be negative?
Positive.
We want the product to be positive. Is this a winner for us? Yes. Do you guys want me to tell you a little trick here? If the first column is the winner, the third column's also a winner. And the middle column won't work. If the middle column works, guess what? The first and the last will not work. Just to show you that the middle one will not work. So the middle column saying pick a number between -2 and +2. Is 0 between -2 and +2? Yeah, so I'm going to test 0. When we test 0, once again, we're going to do 0 minus 2. Do we all agree 0 minus 2 is negative? And then we're going to test here 0 plus 2. 0 plus 2 is positive. A negative times a positive, isn't that a negative? We want a positive product, not a negative one, so that middle one doesn't work. So my two answers for the domain are this and this. All right, let me show you how we write this. So we'll do set notation. So we write x such that, x and then a slash, x is less than or equal to -2, and then you write the word or, x is greater than or equal to +2. That's it. So you just write your two answers in there. I know that's a lot.
I just wanted to go back. How did you find like how to use like the 3 and the -1, -3 and -1.
I didn't use -1. You mean 0?
Yeah, totally.
Okay. I picked numbers. It didn't have to be those numbers.
Yeah.
I picked numbers that fit into the category. So they said pick a number less than -2.
Okay.
So that's where I chose -3. I just chose any number that's less than -2.
So you have to plug it and test it out.
You plug it and test it out. Let's do another one of these, okay? Let's try another one.
Can you go up a little to the side?
Oh, sure.
This is an addition.
Okay. Can I keep going? Okay. Find the domain. F of x is equal to the square root in parentheses x plus 3 and in another parenthesis x minus 4. I actually made this one a little bit easier for you because what did I already do for you? I already factored it, so you don't have to factor it, which makes it a little bit easier. Do we agree the red flag here is the radical? We can't have anything in the radical be negative. So what am I going to do? I'm going to take what's underneath my radical, x plus 3 and x minus 4. And now what sign am I putting here? Is it not equal to? Is it greater than? Or is it greater than or equal to? 0. Which one? Not equal to 0, greater than or equal to 0, or just greater than 0? Greater than or equal to. You got it. Greater than or equal to. So I skipped a step for you. I factored it. But do you guys agree that if this were not factored, this would be a quadratic inequality? So you have to recognize that this is a quadratic inequality. And then you have to recognize if this is a quadratic inequality, what is the process we do? We have to test the regions, that whole long process I just showed you, which is pretty brutal, I know. Right? So we need to test the region. So I'm going to put a star here. Quadratic inequality, test the regions. Okay, try to look back, try to think back so you could do this when I'm not walking you through it. All right, what do we have to decide first? It's already factored. Step 1 is factored. We've already factored it. So what do we do now? Not Nico, somebody else. He's holding up the class. What do we do?
We have my notes.
Good. We have to find our reference numbers. How do we find our reference numbers? How do we find our reference numbers? Tice, was your hand up or no?
Sure.
Sure.
You write x plus 3 and x minus 4, and you subtract the 3 and you add 4.
Good. Are you guys okay if I just write my reference numbers -3 and my reference numbers +4? Are you guys good with that? Okay. So now that we know our reference numbers, what do I do now? Once we know our reference numbers, then what do we do?
Test the region.
Good. So remember, when we're testing the regions, we're going to go to our smallest number first. What's our smallest number between our reference numbers? -3. So I'm going to test all numbers that are less than or equal to -3. Then we're going to test the numbers between the two reference numbers. So we're going to be negative 3 is less than or equal to x, which is less than or equal to 4. What's the last region I test? So smaller than the smallest number, between the two numbers, you got it. Greater than or equal to the largest number. All right, so I feel like most times kids could actually get up to here. Most students could get up to this point, and then they forget what to do from there. So just follow your chart. So we need a number that is less than negative 3. What number is less than negative 3? Negative 4. So how am I going to do this? I'm going to test negative 4. So I'm testing negative 4, so we are negative 4 plus 3. Do we agree negative 4 plus 3 is a negative? So we got a negative here. Then I'm going to test here. Negative 4 minus 4. Well, isn't negative 4 minus 4 negative 8? So that's another negative. A negative times a negative is a positive. So if this one works, right, don't we want it to be positive since it's greater than? If it were less than, what would we want it to be? If it were less than, then it would have to be negative when we multiplied. But we want it to be positive. So if the first one works, which other one's going to work? The last one. Will the middle one work? No. So then we are going to do x such that x is less than or equal to negative 3 or x is greater than or equal to 4. All right, and we are going to stop here.